Welcome to Anatomy 101. So glad you're here. Whether you're on your way to becoming a doctor or you're just totally fascinated by how we humans tick, you're about to take a deep dive into the most incredible machine on the planet, the human body. Think of this as your foundational map. Let's get right into it. So let's start with a big question, right? This is pretty much the fundamental challenge of medicine. You can't just, peek inside someone to see what's going on. So how on earth did we develop what is essentially a universal GPS to navigate our own internal universe? Well, that's exactly what we're going to find out. Here's our game plan for today. First up, we're going to draw the map itself. Then we'll unpack the body's amazing nested structure. After that, we'll get into the body's constant search for balance, identify its 4 essential building blocks, and finally, we'll see how all this knowledge lets doctors look right through our skin. All right, first things first, we desperately need a common language. I mean, think about it. Whether you're a surgeon in Tokyo or a paramedic in Toronto, you have to have a universal frame of reference to talk about the body accurately. No room for error. And this is it. This is our universal starting point. It's called the anatomical position, and if there's one thing you master today, let it be this. Because it doesn't matter how a patient is actually positioned, lying down, sitting, whatever. In the language of anatomy, we always describe them from this one neutral stance. It just wipes out all the confusion. Go ahead and burn this image into your brain. Standing straight up, facing forward, arms at the side. And here's the key detail, palms facing forward. Now, why does that little detail matter so much? Because every single directional term we use, superior for up, inferior for down, anterior for front, it's all based on this exact starting point. Okay, so now that we have our reference point set, we can start to slice into the body to see what's inside. We do this virtually, of course, using 3 imaginary flat surfaces we call anatomical planes. I want you to think of them kind of like panes of glass that let us see the body from different angles. So first, we've got the vertical cuts. The coronal plane, also called the frontal plane, divides the body into front and back halves. Then you have the sagittal plane, which slices it vertically into left and right sides. Oh, and a little bonus fact. If that sagittal cut is perfectly centered right down the midline, it gets a special name, the mid-sagittal plane. And finally, we have the horizontal cut, the transverse plane. This one is like taking a slice right out of a loaf of bread, giving you a cross-section. This top-down view is absolutely essential for reading modern medical images, like CT scans. You're going to see it all the time. All right, we've got our map. Now let's explore the territory. You see, the body isn't just some bag of organs. Nope, it's a total masterpiece of hierarchical organization, built from the tiniest microscopic parts all the way up. You know, the absolute best way to get your head around the body's structure is to picture it like a set of those Russian nesting dolls. We're going to start with the smallest, tiniest doll and see how each level fits perfectly inside the next, building more and more complexity as we go. So let's unpack these dolls. We start super small, at the chemical level, with things like atoms and molecules. Those build our cells, the smallest units of life. Then, cells team up to form tissues. Tissues combine to create organs, like the heart. Organs then work together in organ systems, like the circulatory system. And finally, all those systems come together to create the organism. Yep, you guessed it, that's the biggest doll in the set. So what's the point of all this incredibly intricate organization? What is the one big goal that all these nesting dolls are working together to achieve? Well, the answer comes down to a single, super important concept, balance. And that balance has a name, homeostasis. Now listen, this might just be the single most important idea in all of physiology. Think of it as your body's internal thermostat, and it's always on, constantly working to keep everything from your temperature to your blood sugar in a perfect, narrow, life-sustaining range. When homeostasis is humming along, you are healthy, period. So how does it work? Mostly through something called negative feedback loops. Let's use a fever as an example. The stimulus is your temperature rising. Receptors in your skin and brain detect that change. Your brain, which is the control center, gets the memo and tells your sweat glands, the effectors, to get to work. The response? You sweat, your body cools down, and that counteracts the initial stimulus. It's the body's self-regulating genius right there in action. And this right here is the critical takeaway. Disease is, simply put, a failure of homeostasis. When that balance gets thrown off at any level of our nesting doll, could be a flaw in a molecule, a rogue cancer cell, a failing organ, the entire system feels it. That imbalance is the disease. So let's zoom back in on one of those nesting doll levels, tissue. It's actually incredible when you think about it. Every single part of your body, from your brain to the skin on your hands, is built from just 4 basic types of tissue. And here they are, our 4 core building blocks. You've got epithelial tissue, which covers surfaces and lines cavities. Then there's connective tissue. That's kind of the glue that supports everything from our bones to our blood. Third is muscular tissue, which is designed for one thing, contraction and movement. And fourth, we have nervous tissue, the body's high-speed wiring for communication. Every single organ is just a unique recipe using these 4 ingredients. Okay, let's put it all together now. How does all this foundational knowledge, the planes, the organization, homeostasis, the tissues, how does it actually help save lives in the real world? Well, remember those anatomical planes we talked about? They are not just some abstract concept in a textbook. They are the literal blueprint for medical imaging. A CT scan, an MRI, an X-ray, it's just a machine taking a picture of the body along one of those exact planes. It's how we find a disruption to homeostasis without ever making a single cut. And here's a super simple everyday example. By drawing a sagittal and a transverse plane over the abdomen, clinicians create 4 quadrants. So now, when a patient says it hurts right here, the doctor has an instant map, which helps them narrow down which organs might be causing the trouble. It's simple but so effective. All right, pop quiz, quick knowledge check. You're looking at a brain CT scan, and it's giving you this amazing cross-section. It's a slice that separates the top of the brain from the bottom. So, which plane are we looking at? Come on, you know this one. It's the horizontal slice. If you said the transverse or axial plane, you are 100% correct. Nice work. So, what's the big takeaway here? Anatomy isn't just memorizing a bunch of parts. It's about learning a new language so you can read a deeply complex map. Like it says here, the body is a whole universe of coordinated systems. You can't possibly fix a machine if you don't have the blueprints. Master these concepts and